My name is Jessica Bollerna. I'm a former CIROH postdoc who's studying barriers to implementation of nature-based solutions, but I'm now working for the Climate Measurement Center of Excellence, a new partnership between the National Institute for Standards and Technology and the Gund Institute for Environment here at UVM. I'm super excited to introduce you all to Dr. Gillian Galford, who is the director of this new center. Dr. Galford has an interdisciplinary background in ecology, geology, and the social sciences, and a long track record of conducting applied research focused on improving communities' ability to understand and adapt and address climate change. She has spearheaded Vermont's first, second, and soon-to-be third climate impact assessments, and her work in Vermont has really led to the development of this new Center of Excellence. Under her guidance, the center's ultimate goal is to help communities across the U.S. who want to complete their own subnational climate assessments access resources, guides, and toolkits to create successful assessments based in the best available science. With that, I will turn it over to Dr. Gillian Galford to present her talk entitled Understanding Weather and Climate on Scales That Matter to Communities. If we can give her a warm welcome.
Hi. This is actually the second time I've been taking the stage after a senator has warmed up the group, Bernie Sanders and now Peter Welch. So I'm going to talk really about the Vermont context and our experience with the Vermont climate assessment, and then sort of looking forward in terms of how we work with other states on assessments. So my overview for today is really thinking about why do we do assessment, how do we do assessment, what we find here in Vermont, which I hope is interesting and you learn something, and where we're going with this network that we're building. So I'll really today focus on the Vermont climate assessment as sort of a case study to explain what we've done here. Also gives you guys hopefully an introduction to what's happening particularly in the water world of Vermont. As Jessica said, the third climate assessment is now underway here in Vermont. So first, why do we do climate assessments? We all know that there's these big changes in natural hazards. You guys probably look at them in terms of water. A lot of communities are seeking resilient strategies to prepare for the next extreme event. And most communities need local or contextualized information. And I'm going to give you guys an example of that, or lots of examples today. But what is a climate assessment? It's usually a mix of something like a review, maybe some downscaling or statistical work with existing data, sort of like a meta-analysis. It's not usually going out and collecting a whole lot of new data. And a great analogy is if you ever look at the National Climate Assessment, that they are collecting existing information and moving forward from there. So why do we need it if we have the National Climate Assessment? I know these maps are a little bit small, but they're one of my favorites. When I teach, I tend to find that people look at where they're from, or where they live, or where they want to go fishing on a map. So if you take a look at these maps, I'd focus particularly on the ones on the right. So this is historical trends in heavy precipitation events. So the heaviest 1%, and we're in that dark blue region. We're having a 55% increase in the heaviest events. And in the future, oh look, we're also in that dark blue region. So this is projected change in annual precipitation over 40%. You guys, I don't know, people, Alabama, I heard Utah's here today. You know, you can look at where you are around the country and think about what that means. But if you're in Vermont, it means you're sort of color-coded in this bin with like all of the Northeast. Like all of the Northeast is experiencing extreme precipitation. And if you live in Vermont, as we heard from our senator earlier, that doesn't mean a whole lot, right? When my house didn't flood, but a house down the road flooded 3 times in the last year and a half, that local context is really missing here. And it's very hard for someone like a regional planning commission, a state senator to actually make decisions when they're looking at something that lumps them together with Pennsylvania, not a state that we really find a lot of similarities in terms of water management decision making. So that's some of the reasons we need really that local context to make information more action ready, or at least sufficient for decision support. So how do we assess? I'm going to tell you what we do in Vermont. And remember that this is a Vermont-specific approach. It may be different in other states, and we are learning from other states to sort of develop a suite of best practices. But we're a state that has no legal mandate to do the climate assessment. We have no state funding, and we're run independently through the University of Vermont. That's really different than some other states, just so you know. So we use our strengths. And some of the things that we really lean on are these sort of principles. We have to have credibility. Guess what? If you're affiliated with the university, you're usually seen as being very credible. Maybe not in every circle, but in general, people trust that the science and information coming out of a university is credible. Salient. So again, that first map I showed you was not very salient to Vermont because it was sort of lumping all of Vermont and in fact all of New England into one category. It didn't really resonate with the local questions or local experiences people have. And the last one is legitimacy. How is an assessment done? Is it done in a process that's transparent, that's fair, that's inclusive, and so on? I like to think about the assessment process as really engaging a network of people, and the process and the ultimate report as being sort of this boundary spanning document or process, right, that brings different groups together because we're interacting on this one thing, our state climate assessment. So a lot of us are sort of maybe over on the left, researchers, scientists, and we like to use the words stakeholders or decision makers, but the fact of the matter is I'm not talking to every person in Vermont, and I'm not providing information to every person in Vermont. What I'm doing is I'm talking to what we call knowledge brokers, so people who maybe represent the Vermont Fruit and Veg Growers Association, maybe the director of the Vermont League of Emergency Managers, people who know what's going on in their community, they know what the needs are for information, but once we create that information and bundle it up for them in the climate assessment, they also become the spokespeople who then are communicating and relaying that information within their communities. So this network and this back and forth and interplay, early engagement with all these knowledge brokers is really important. We also take a team science approach. These are the lead authors from the 2020 report. I know at least one or two of them are in the room, and there's probably lots of other people who contributed either through things like peer review, research development, sometimes a short call-out box, a 2-page entry, but we covered 11 different subjects and really use this team-based approach. So these authors are working with a whole team of people, but they're also working within the team to coordinate. Say a complex topic like overbrowsing by deer and its impacts on forest ecology. Does that go in the forest section? Or does that go in the fish and wildlife section, right? So we have to really work as a team and create as many synergies between all these different teams as possible. That's a quick overview of our process. Oh, I was asked to highlight that these lead authors are all students. So there's nobody really getting paid to do this work, as I said. Faculty don't have time to do it. People in the state don't have time to do it, but it's an amazing training experience for these graduate students. They work very closely with faculty advisors. They work very closely with people in our state government, in nonprofits, in business, in research groups, and so on and so forth, all around Vermont. And all of them, in some way or another, have really leveraged this experience into their career once they leave UVM. Okay, so let's get to the good stuff. What do we find? Big shocker here. Climate is changing. It's getting warmer, and it's getting wetter, which is maybe different than the rest of the country. If you remember that dark blue on the map, right? We're really talking about extreme precipitation, lots of water here. We're also seeing compounding events, right? So one thing happens on top of another. And I'll tell you, somebody asked about like warning for the flood Senator Welch was talking about. So let's take a moment to think about today. It's sunny and beautiful, like Vermont put on its best for you. But if you arrived before Monday, you may have noticed that we've been in several weeks of rain, just rain, rain, rain. So we're in a condition right now where rivers are, at least the ones I've seen around the state, are pretty close to bank full. Our soils are heavily saturated, and we're okay. But if there's a big storm that comes soon, could be July, could be August, we may be in those conditions, like in Tropical Storm Irene. That came after a very wet spring, and the water just didn't have anywhere else to go but flooding. So just there's maybe a warning if you're living in Vermont that I think we're setting up for conditions that, unless we have an incredibly dry summer, could lead to a lot of flooding. Some of the data available that we pull into the climate assessment comes from this awesome report that NOAA did with a bunch of state climatologists. Our own Leslie-Ann Dupini-Giroux helped with this one. So this is climate modeling, looking at different emission scenarios for Vermont. We're already in about this 3 degrees Fahrenheit increased temperature regime compared to the historical period shown in gray. The higher end of the high emissions would take us to about 12 degrees by 2100. Some states have a lot of capacity for climate downscaling, right? Doing modeling that maybe gets granular within the level of Vermont. Connecticut is really good at that, for example, if you want to look at a state that's done a lot of that. We don't have a lot of capacity for that or a lot of time to do that work. There's no one who's kind of doing it as their ongoing research agenda, at least not spatial climate modeling within Vermont. So what do? One thing we do is we look at what's happened in the recent past, and the trends, particularly over the last few decades, help us talk about what's coming down the pipeline in 10, 20, 30-year intervals, which is much more relevant to most people making decisions than showing a graph of 2100, which is really hard to relate to. So, oops, did I skip it? Oh, no, okay. So winter is a big question here, especially if you're a skier. We see that winters are getting colder, and one, I think, of the very powerful things that we can do in the climate assessment is we have the sort of the luxury to go into the details. So not just looking at what is the average temperature of winter doing, but let's look at this. Let's think about, on the left, we have the number of cold days. So this is the high temperature, and we're actually declining in that area. So we're getting warmer, but we're also having warmer nights, which is shown on the right. So these are days above 50 degrees Fahrenheit during the winter months. That's a big problem if you're in the ski industry and you want to keep snow on the ground, right? So we start having snow melt. It's also a big problem if you live in a place like Vermont that is increasingly experiencing rain on snow events, which I know in the hydrology community you follow very closely. But it's not just in winter, sorry to tell you, Ed, but it's also in the summer. And so this is kind of why should we care about things like stream temperature? Well, in Vermont, recreation like fly fishing, you should have brought your fly rod, is a really important economic activity that brings in a lot of visitors and unfortunately can suffer when we have things like this beautiful photo of a very tragic fish kill. Precipitation, overall, more water. I'd like to just put these numbers in context. I grew up in Portland, Oregon, which people think of as a really rainy place, but Portland and Seattle get about 37 inches of rainfall a year, so we're actually sort of on these low blue bars. That's about what Vermont was historically, and Vermont's now moving up in this 44, 45 sort of range, which actually is more like Central Park in New York City, gets almost 49 inches of rain per year. But not all rain is falling equally. So I put that same graph now on your left, our total annual rainfall. And on the right is the number of heavy precipitation days. So that's a day, a 24-hour period, where precipitation exceeds 1 inch. And as you can see, we're now getting about 8 of those. So if you took 8 inches of extreme storm rainfall and added it to our average of 37, you put us right at that 45 ballpark. So I think this is really interesting, and it's actually very important for people who are planning for increased precipitation, is that it's not that every storm is getting a little bit more rain. It's these heavy storms are coming more frequently. And in fact, what I think we're seeing now is that these heavy storms are getting really, really big. So, we define heavy precipitation as more than 1 inch in that 24-hour period. And 2 summers ago, I got a call from a reporter, and she said, this town I'm reporting from, it's experiencing a ton of road damage and such, and people are talking about it, but I don't really know if this is a big flood event. Can you help me understand? I mean, they only got 6 inches of precipitation. It's this is a big flood. That's a lot of rain. And in the storms that Senator Welch was talking about last summer, there were a lot of communities that experienced, I hadn't heard of 11 inches, but I've heard of a lot of communities that got 8 inches in a day, which is just, in my mind, very, very mind-boggling. If you're a skier, the outlook is mixed. So in theory, we're in a climate sweet spot where we're getting more winter precipitation, and we're still in this colder winter period. But as we saw, that can be very variable depending on winter temperatures. So a lot of variability there. Okay, so once this water's on the landscape, where does it go? This is some work that was started by Kristen Underwood and has been carried out in every Vermont climate assessment. Kind of eye candy here. The point is that we pulled stream gauge data. This is annual stream flow over time, so going back to 1960, and just everything is increasing, right? And there's lots of other metrics that could be pulled here, maybe more interesting metrics, the time at bank full and so on and so forth, but I think this trend will hold through almost all those metrics. Again, we can get a little bit more granular and actually start looking at the seasons. And one of the questions that we got asked specifically, sorry, this is spring, winter, spring, summer, fall, winter, spring, summer, fall for all these different rivers. So they're all increasing except for in spring where it's sort of hard to figure out. Maybe there's a signal for some, maybe there's not, but not as uniform of a trend. And we actually got asked by the Vermont ski industry, what's happening to February mean flow? Does anyone know why February mean flow is important? Beverly does. It dictates snowmaking withdrawals. So they're legal, snowmaking, say a ski resort is legally tied to the February mean flow for their water source. And we found that it's increasing. So that was actually, to the ski industry, very, very encouraging news as they are continuing to build out snowmaking as an adaptation activity for changing winters. And when this water moves through our landscapes, say our upland areas where roads turn into rivers, our floodplain development that gets flooded, our crops that get destroyed, our lake that gets inundated with nutrients and eventually turns that into harmful algal blooms. It's not just a story of too much water, it's really what happens to all the communities that are here. This is a focus on a particular station. This is Rutland Station, which is in southern Vermont. They asked me to come and talk to them about the findings from the 2014 climate assessment. I think I was there in 2015. I said, listen, this is the number of days of heavy precipitation, more than 1 inch in that 24-hour period. And, you know, in the 1960s, this town was at 4 or 5 days of extreme precipitation. And by this point, again, this is coming off of that tropical storm Irene in 2011, they were in that range of 10 or 12 or so. And they spent an hour deliberating over this data, and the Regional Planning Commission left that meeting saying, we are now committed to systematically upgrading any culvert that we have the opportunity to replace when we're doing any sort of road maintenance. And that's what it took. Like, they wouldn't make that decision when they looked at the National Climate Assessment. It took actual data where they were like, okay, we are experiencing this, we're not crazy, it's a trend, and let's start to prepare for that. I pulled the data for that station a few years later because we went into what we had predicted in 2014 as increasing dry periods. So alternating in Vermont now from these really heavy periods, like 12 days of heavy rain, to actually very dry periods. In the last few years, here, even before the floods that Senator Walsh was talking about, we have been experiencing droughts. I want to make one point just about the problem with average. We're blessed in Vermont with having some meteorological stations that go back to the 1800s, but you can see if we plot a nice average trend line on it, we actually completely miss what's happening in the most recent few decades. So just my word of encouragement as data scientists, to be really thinking about what the patterns are that you're representing. And again, things like extremes can be incredibly important, more so than just the long-term trend. I'm gonna give just 2 more examples and then I'll be done. So the other thing we get asked a lot is, how is growing season changing? What might this mean for agriculture? And so in the center, this is how our growing season has changed. I mean, it's incredible changes. We're talking about on the order of 40 more days in our growing season. There's new crops that have never been grown before. But we also were able to do this analysis. This is moving from the southern part of Vermont to the more northern part of Vermont. And certainly the trend is clearer and more pronounced, as you might expect in southern Vermont. But again, this is just a way to make data really salient to the people who are in these areas making decisions. I want to highlight just this citizen science story. If you're not from a northern area, you might not know about something called ice out. Ice out is the time when the lake loses its ice. This is Joe's Pond, where you can actually buy a ticket to bet on the date and time that the ice will melt every year. And you should do that because it's a fundraiser for their 4th of July fireworks show. We know fireworks are getting expensive. But the pool is huge. I don't know, it's like $5,000 or something that you win if you get it right. And what they do is they tie this cinder block on a pallet in the lake and they hook it to an alarm clock. They use that same alarm clock for I think 30 some years. About, I think it was 5 or 7 years ago, they had to get a new alarm clock. But when the block falls through the ice, the alarm clock gets unplugged and records the exact time. So sometimes it's 2:36 a.m., sometimes it's, noon on a Wednesday. But what they did is they have always recorded that time and date. So we actually see in the time that they've been recording data that ice out is happening about 5 or 6 days earlier than when they started this record. So super noisy, but a really compelling story. And I actually think of all the science and the data that you might see this week, it's these compelling narratives that may resonate the most, that are the types of things that you take home with you. And it does work. It works here in Vermont. So we go back and we think about how well do we do in these 3 areas: credibility, salience, legitimacy. We go back, we talk to our knowledge brokers, we find out how are they using our information, what can we do better next time, and so on. So some examples, people from the Regional Planning Commission saying, like, here's how we've used this. Someone actually making rules in the Department of Environmental Conservation and saying, hey, we're citing your report as part of the basis for our rulemaking. We're interpreting this law and making a rule. We need to cite your report. And in fact, being cited in legal acts that reference the climate assessment as part of their basis. But locally, this information is super salient. So highlighting our appearance in local news outlets, but also what's happening in Vermont has been picked up nationally. So the Wall Street Journal talking about winter recreation opportunities, dairy farmers appearing in the Washington Post, floods appearing on the New York Times. So all of these experiences led us to develop this Climate Measurement Center of Excellence. We're really focused on how can we support areas like Vermont and Alabama and other states that don't have or want to improve their climate assessment process to deliver information that is credible, salient, legitimate, and really drives decision-making on the ground level. So that's what we're here for, and that's what we're doing. I'd love to talk to you more about CMEC if you're interested. Thank you very much.